Okay, so today I'm going to show how to set up the Nvidia GPU drivers on AlmaLinux. I'm going to do this because AlmaLinux is one of the rebuilds of Red Hat Enterprise Linux. It's the community-supported one, so there are others like Rocky and Oracle, but they're supported by corporations. And for some reason, Nvidia seem not very keen on officially supporting AlmaLinux, but it's close enough to CentOS that actually we can follow the instructions for that. So why AlmaLinux? So it's community driven. I actually started using it over Rocky. If you look at my videos, I've got some older videos with Rocky, predominantly because I have a bunch of Raspberry Pis and lets me run Enterprise Linux on those because Alma provided an image for that. But if you use WSL or supported images for that, the images for various containers, Vagrant, we're actually going to use it in the cloud today. I have imaged a Amazon instance with an Nvidia A10G in it using the official AlmaLinux AMI from the marketplace. You can subscribe to that and you can launch instances. Subscription is free, right? Because it is a open source operating system. So I have an instance here that I've created. I'm just going to secure shell into it. This is completely like untouched. As you can see, it's not even in my keychain. Okay, so we're logged into the instance. It's got a fresh install of AlmaLinux. If we look in etc. Red Hat, release. See, it's AlmaLinux release 9.3. That said, we should certainly do a DNF update. There will be security updates. And unfortunately, this will also bring in a kernel update, so we probably need to do a reboot. We should do a kernel reboot, obviously. So first, you see anyway, is don't even have the GPG key in DNF. So obviously this key comes from the file system as part of the image. It's fine, so we import that. So the NVIDIA stuff uses DKMS and needs the kernel source. So we need to make sure that matches, but also obviously we want to have the newest kernel because we want to have all the security fixes. So we'll let that chug away there. If we look at the instructions on NVIDIA's website, they have instructions for a bunch of operating systems. These are actually slightly older looking instructions, but they've got instructions for Red Hat Enterprise Linux 8 and CentOS 8. We're going to adapt these. They're pretty much the same on AlmaLinux, except we're obviously going to need to do Red Hat 9 or CentOS 9. An interesting point here, this is repeated in various versions of the instructions, and I'm not quite sure why. NVIDIA doing something odd here. So all this is doing is setting an environment variable equal to Red Hat 8, but they say that's setting the CUDA key. It's not doing that. Okay. So it looks like DNF has almost finished updating. Let's have a look. And then we'll do a reboot. And then log back in, and then we can do the main updates. Second time we log in, I'm going to do a port forward because at the end of this, I'm going to do something in Stable Diffusion in a Jupyter Notebook to show that this is working. And I always think that's nice to do. So I'll just do the port forward. I'll log in. Right, so it's finished installing and I've told it to reboot. It should now be back. So let's secure shell in with the port forwarding. Go. Okay, should be logged in. So apart from doing the software update, we've not installed anything else, but there's a bunch of things we'll need to do to make this a more usable machine. I like to install a bunch of packages like Screen and Vim. Screen is not actually in the base image packages anymore in Red Hat-based distributions. I don't know why. But in order to make NVIDIA's stuff work, we need to install Apple and the Code Ready Builder repository anyway. So we do this on AlmaLinux and CentOS derivatives. It's different from Red Hat Enterprise Linux, but they actually provide you with the instructions on their website. For CRB, we need to do this DNF config manager set enabled CRB. So let's do that as root. Okay, that should enable code ready build repository. And then we can actually just install Apple as a package. Again, you can't do this easily on Red Hat Enterprise Linux. It's more complicated because there's a whole bunch of stuff around subscription manager. But you can find instructions online on how to do that. If we install Apple-release, we should now have the Apple package, the Apple repo added to our system as well. So I'm now just going to install some packages that I find fairly helpful. So that's usually Vim, Screen. So there is a minimal version of Vi installed when you set up the machine, which is based on Vim, but I like to have all the stuff there. I quite like to, it's less necessary on this system to have bind utils and net tools, but I don't know, I find them useful. And we'll note that now it's actually checking the Apple repo for updates as well, so that's good. So that's all set up properly. Okay, and it should pull in those packages. It's going to check the, again, now we have to import the Apple key, right? That's also on the file system, that's fine. And now I should be able to make my life easier by using Vim. Final thing I'm going to do is I'm going to install some Python packages, because we'll need those later. So they are pip and virtualenv. We'll also need git, because that's not in the base image. Oops. Okay. And this is just because we're going to do the stable diffusion stuff afterwards. Right. I am going to pop out the shell and use screen. So I have screen. Right. So the next steps we have to do, if we look at the instructions, are we need to. So here they are doing the same thing, right? So in CentOS, it's called 8, it's called Power Tools, but they're doing the same things running here. The next thing we need to do is add the Nvidia repository. There's also a bunch of dependencies we will need for predominantly for building the kernel modules, actually. So let's install those. So if we do dnf install for those, and also we'll need kernel devel, kernel there's all those. So the next thing we'll have to do once that's installed is we'll have to add the Nvidia repository. Obviously this is showing us the stuff for Red Hat 8, but if we poke around we should be able to see that there's in fact the stuff for Red Hat 9 in there as well. I'm going to switch this over to the HTTPS version, just for that comforting level of security. And we can see in here there's in fact a Red Hat 9 repository with x86-64. And if we search for repo in here, we'll find the repo file that we need to install, which is here. So let's copy that link. So to add the configuration manager, we do just ping my DNF config manager. Dash add dash repo, then that URL we have there. Okay. Doing over HTTPS, and that's important because we want to get the GPG key over HTTPS. So that repo should be in there. If we go into /etc/repos.d, we should have a CUDA rel9 repo. If we cap that, you can see that that will indeed pull the key over the HTTPS. To make sure we've not been like weirdly typo squatted, let's make sure that those URLs are sensible. We want it to be HTTPS developer.down. We're typing Nvidia. Okay, fine. It's at least been published by Nvidia, so we should be fine. So we've installed the dependencies from the Red Hat, from the AlmaLinux repositories. We know to install Nvidia drivers. If we look at the installation instructions, we'll see that there are do it by doing DNF module install, and then we need to pick a stream and a profile. We can use the default profile because that seems sensible. We're going to use the latest DKMS version of the driver stream, and that means that it'll have the DKMS modules, which will recompile when we update the kernel. So we want to install test DKMS slash and just default uppercase or lowercase. Right, so it's pulled down the key. It's told us it's pulled it off the HTTPS URL. Good. Fine, so let's pull it in. This will take a little while because it needs to build DKMS modules. So while it's doing that, let's flip over to my user and set up some of the Python stuff. So I have a repository of tools for generative AI, which I'm going to clone. And then we can use that later to do the image generation workflows. The second thing we need to do is set up a virtual environment for our stuff. I'm just going to call it GenAI. Don't forget to do that. GenAI bin activate. And then to install the dependencies we need in my LLM playground repository, I have a folder of armors.txt, and we'll need to use two, one for the actual packages and one for a tool called NVI top, which is quite helpful in showing what's going on. So let's first of all text. And that'll pull down Torch and the Nvidia versions of CUDA and stuff linked to Torch. Actually look what's in there. See, it's just pip torch vision, the diffusers library, and some other stuff that's needed for this. We see it's currently running the scriptlet for building the DKMS modules, so that's excellent. That'll take a little while because it's compiling stuff. The final thing we need to install from DNF is these Python packages depend on the CUDNN libraries, so we'll install them. Specifically, it depends on CUDNN 8, which is no longer the default because 9 is out, but we can install those from DNF. One of the interesting things about installing these video drivers is because you could be doing that for GUI purposes, it pulls in a whole bunch of graphical tools on Linux. You could probably customize your install a bit so it didn't do that, but you can see it's pulled in like Pulse Audio and GStreamer and for some reason Flatpak, which is a packaging thing for applications. It's very similar to Snaps. Okay. Pip will of course whinge because pip is always out of date. Let's update pip. And finally, let's install NVI top, and that's in the user experience requirements text. Do pip install our user experience text. Okay. Let's see. Fantastic. The drivers have installed, so we can now run Nvidia SMI, and that should tell us that we have an Nvidia A10G with 23 gigabytes of RAM. Right, next step, we need to install the library I was just talking about. My brain has just crashed. CUDNN. And we'll see that there's CUDNN 9 and CUDNN 8. So let's install both of those. That should bring in CUDNN dependency. Oops, you can tell it's been a long day. Install. Yeah, I'll bring in 9. Fantastic. Okay. That's quite a big download, so you think it's quite a bloated set of software. And actually, the Stable Diffusion stuff will run without it, but it'll be missing some of the features. So, for performance reasons. That's now installed. So if you remember, we ported port 5100. If we go down a directory, so just go to our directory actually. And now we run Jupyter lab / port equals 5100. Jupyter lab will start up. Then we put forward to 5100. And we copy the URL with our single use token to a web browser. Let's do that. Okay, and so here we are. We are in Jupyter Lab. Let me just zoom in so the stuff is more viewable. I largely prefer to use the console. It's really up to you. And all this script is here is this is a bunch of stuff that makes it easy to run the workflows within Stable Diffusion XL on a bunch of different platforms. So let's pull in a simple routine from that, which makes it easy to generate stuff. So XL import. You can also open a terminal and have a look at the output of NVI top. install, and that's a really nice graphical tool for showing the usage of the GPU. So obviously it's doing nothing at the moment. Let me just flip this into dark mode because that'll make it easier to see things. Can I do it with just the terminal? The thing that frustrates me about Jupyter is the degree to which features just change. And depending on where you are, and because stuff is set by like a dependency graph with other packages, sometimes you'll get wildly different features. Okay, so it's imported that library. That's actually quicker than I was distracted. So now we can generate something. So if we do interactive prompt equals cute penguin afternoon tea. And we will turn on the two-stage denoising thing. Just because, sure. And let's not save the image. I think I've set my float to save by default. Let's run that. Because it's the first time this has been run, it's going to pull the model weights from Hugging Face. Right, and subsequently that'll be cached. Unfortunately, because of the way it prints stuff to the terminal, when it's doing this is slightly hideous in Jupyter notebooks. So if we flip over to the terminal, you'll see that it's actually doing that in the terminal as well with these little progress bars. Okay. Having done that, it will start up the pipeline. This should now be copying stuff over. So you see that the memory is filling up on the card. There's actually two steps here because there is the base model and there's a refiner. So together they use about 12 gigabytes of memory. Probably a bit more than that actually. That's probably just the base model because the refiner's not started yet. So it's doing the base generation, it's doing 80 iterations, and now do the second thing, we just doing the refiner. Oh no, that's it, it's 12 gigabytes of refiner. See the usage on the GPU. So that's the memory. This is effectively the GPU performance usage is finished. And we should have a cute picture of penguin having an afternoon tea with cake. That's it. So that's the Nvidia GPU drivers working properly on top of AlmaLinux. And I am going to shut this down and say goodbye.